Hey, let's go ahead and take a look at this worksheet that you have for homework that asks you to verify some solutions to equations. So what does it mean to be a solution to an equation? Well, remember, an equation is just a statement of sameness. An equation says that this stuff on the left side of the equal sign, whether that's an algebraic expression with some variables or whether it's just numerical, is the same as this stuff on the right side. And in the end, whether it's just a number or you've got some variables, they're both really numbers. Right? This says negative 7x, but that's really a number. Once you know what x is and you can evaluate it, then really you're just saying this number is the same as this number. That statement can sometimes be true when this number actually is the same as that number, and that statement can sometimes be false when this number is not the same as that number. Your job is to check whether or not these proposed solutions that I've written here in ink are, whether they make the equation a true statement, meaning the number on the left side turns out to be the same number on the right side, or if it makes the equation a false statement, if the number on the left turns out different from the number on the right. So I'll do some of them for you. You can do the rest. Let's see here. How about I work straight down the right side? So I'll do all the even ones. So our job here is to check whether or not negative 14 is a solution to the equation 91 equals negative 7x. So what we do is we rewrite the equation. So 91 equals negative 7, but instead of writing x, I'm going to substitute this negative 14 in for x. So negative 7 times negative 14. Then I just evaluate both sides of the equal sign. So to evaluate means to do all the math, all the operations you see, and get to one single number. Well, this side of the equal sign on the left, where there's just 91, that side's already evaluated. It's just a 91. This side, where we have negative 7 times negative 14, that side, on the other hand, does need to be evaluated. We got to do a little multiplication there. So this side, I'm just going to write it again, just to keep my work neat. The negative 7 times negative 14. Well, it's a negative times a negative, so I know my answer is going to be positive. So that's good, because I'm looking for positive 91. But let's see here. I like to do multiplication where I break up the bigger number into pieces. So 7 times 10 is 70. Let me write that over here. I'll just keep it to myself, 70. And then 7 times 4 is 28. If I add those up, I get 98. So negative 7 times negative 14 is 98. Well, 91 does not equal 98. So what we do to indicate that it does not equal is we put a slash through our equal sign there. And since negative 14 didn't make the equation a true statement, it didn't make it so that both numbers on both sides of the equal sign were the same, then it's not a solution to the equation. So what we write is no, negative 14 is not a solution to this equation. We can just write is not a solution. All right, so let's try the next one. This one says the proposed solution. Proposed just means maybe. Maybe this is a solution, maybe it's not. It's our job to check. So the proposed solution is n equals 20. And so the equation is 31 equals 15 plus n. So we rewrite it as 31 equals 15 plus 20. And then we evaluate both sides of the equation. So the left side is obviously already evaluated. It's just a 31. And then on this side, we got to do 15 plus 20. That one is 35. Again, this one did not work. It didn't turn out to be a true equation. We came to a false statement. 31 does not equal 35. So we put a slash through our equal sign to say it does not equal. And we write no, 20 is not a solution. So one thing that students often get confused or mixed up about when they're doing this is you do some math, you do a problem, and you come to an answer at the end that's 35, right? That feels like your answer because you did some math and got a 35. And so a mistake that a lot of students would make is write no, 35 is not a solution. Or maybe no, 31 is not a solution. But these aren't the things you're checking to see whether or not they're a solution. These are the things you're checking to see whether or not they're equal. And if they are equal, then that means the proposed solution, the one we started with, then it is a solution. And if they're not equal, like what's happened in both cases so far, then you would say your proposed solution is not a solution. So just try to remember that it's always the proposed solution that you're trying to make a claim about, yes or no, not the numbers that you get after you evaluate. All right, let's do number 6. So this equation says -1 equals -1 plus n divided by 6. And the proposed solution is n equals -5. So we rewrite the equation, -1 equals -1. Instead of plus n, I'm going to write plus -5 divided by 6. And then I need to evaluate. Obviously the left side is already evaluated, so I'll evaluate the right side. Usually when I'm doing my work, I work downwards, right? Like I write then my next step below. But sometimes when I feel like I have more space to the side, I'll use an arrow to say that my next space is over that way. So, or my next step, I mean, is over that way. So I rewrite the equation, -1 from this side equals, let's see here, -1 plus -5 is -6. And then that needs to be divided by 6. And so then my next step is going to be down here. So I rewrite it again. I've still got the -1 from the left side. And that's supposed to equal -6 divided by 6 is -1. So this is a true equation. Finally, we got one where it worked out so that the number on both sides of the equal sign is the same. And so what I like to do sometimes is I put a little check mark next to it to say, yeah, that one worked. And what we write is, yes, -1 is a solution. I just did the same thing that I just literally told you not to do, and I didn't even do it on purpose, like on some teacher stuff. I just really actually did it. This is not the number that we're supposed to write is a solution. These are the numbers we got after we evaluated the expressions when we were checking to see whether or not this was a solution. So I just messed up. I didn't want to say yes, -1 is a solution. I wanted to write yes, -5 is a solution because it made the equation a true statement. All right, let's do the next one. 8 plus 9x equals 179. And the proposed solution is 19. That's what we're checking. So let's rewrite the equation. 8 plus 9 times 19 equals 179. And so this time we got to evaluate the left side and see if it comes out equal to 179. So let's see here, we got to do 8 plus, so I'm going to break this up into pieces. 9 times the 10 is 90, so I'm going to do a little side thing over here and I'm going to write 90 just to remind myself. And then 9 times 9 is 81, so I'll write a little 81 there. Let's see here, 90 plus 81 is 171. So I need to do 8 plus 171 equals 179. And so 8 plus 171 is 179. That does indeed equal 179. So x equals 19 made this a true statement. It made it so that we got both numbers, the same number on both sides of the equation. So I put my little check mark and I write, yes, 19, not 179. I'm going to make sure to do it right this time. We're checking 19. Yes, 19 is a solution to this equation. I like to abbreviate equation as EQ a lot. All right, and then the last one, for me anyways, you got 5 more to do. -7 plus 10 times b equals 173. So we rewrite it as -7 plus 10 times our proposed solution, which is 20. So 10 times 20. And that's supposed to equal 173. We'll see if it actually does. So we need to do -7 plus 10 times 20 equals 200. And we're checking to see if that equals 173. Well, 200 plus -7, that's just the same thing as 200 minus 7. So that's 193. and that does not equal 173. So let's put a slash through our equal sign. And if you want, you could put slashes through all the equal signs really, because it was never equal to start with. So, you know, it wasn't equal here, it wasn't equal here, it wasn't equal here. And so because this one did not make a true statement, it made a false statement, we write no 20, remember we're checking this number up here, not the numbers that we got down here, is not a solution. All right, there you go. Do the other 5.